Good morning or good afternoon, depending on where you are. My name is Professor Duke Orata. We are continuing with our lectures in thermodynamics. And today I want to focus on internal combustion engines. These are some of the most important machines which serve a lot of purpose, the humankind. They are used in transportation, vehicles depend on them, are mostly powered by them, whether it is aeroplanes, whether it's machines in industries. These are critical equipment. These are called critical equipment for progress in any system or in any country. Now, the internal combustion engine, as you have said, is one of the most important machines. So let's look at broadly, first of all, what kind of arrangements are there in an engine before we work on the individual processes in this four-stroke engine. There's the two-stroke engine, which is a lot simpler as compared to the four-stroke engine. So once you're conversant with the four-stroke engine, the two-stroke engine should not be an issue. Now, let us look in a schematic what we have. That's called the cylinder head. The engine, you're looking at the front view. Then we have our valves. We have our valves. This will be the intake valve. And this will be the exhaust valve. And so here we have our piston. Let's try to draw it as best as we can. We have our piston. We have our piston. Let's try to get it drawn as best as we can, so that is perfectly fitting. So we have our piston. And this piston normally will have rings. And these rings normally are on this piston, and they have to be fitted in the cylinder, and so you normally need what's called a ring squeezer to tighten them, and then you are able to push in the piston in the cylinder wall, in the cylinder unit, without causing breakages to those particular rings. So in most cases, you will have a compression ring, one we'll definitely have an oil ring. These two are very common. Those two are particularly common. And so we have our ring there. We are trying to get it as a schematic. So we are having our ring there. Of course, we have our TDC, that's the top dead center. And let's say we have our bottom dead center here. And of course, there's a stroke. We are already now familiar with this because we have talked about them quite extensively. And of course, in these particular valves, we have the valve buckets. So that will be the intake valve bucket. That will be the exhaust valve bucket. And of course, remember, we have the combustion chamber and so forth. And we can have a spark plug. That will be the case in the case of spark ignition engines. But you also have the diesel engines where the gas is compressed and then you inject fuel. Because of the high temperatures, combustion starts. That's called a compression. So we have talked about spark ignition engine, like I've indicated spark there, or can have compression ignition engine. So this is typical of diesel vehicles. These are petrol engines. Now, we know that we have, of course, here where we have the piston in this housing, this is basically the engine block. This engine block houses very many things, very many things. Down there, there's the sump, we have the clutch units, we have the flywheel, they are all over. There are many things which it's in contact with. And in itself, it has also channels through which water can run out for cooling the systems and very many other things attached to it, into this engine block. So basically, we have the cylinder head and the engine block. And we said, remember, in our lectures that it's very, very important that the clearance volume is sufficient so that we don't have the piston hitting the cylinder head. That would cause a lot of damage. Now, and these valves also are very important. In fact, asymmetry in these valves can reduce the power of the vehicle significantly. So these valves are always supposed to sit on a valve sheet, which it should fit perfectly. In case the engine is aged and probably has been redone again, has been rebuilt, they will actually have to grind the valves using a paste grinder, which has both coarse and smooth fine ends. They grind those so that they get the valves to lie properly on the sheeting which it has. Now, we have the engine block. So we have our engine block here. And of course, we know we have a connecting rod, a rod connecting this piston to the crankshaft. Connecting the piston to the crankshaft. Let's call that crankshaft. And here we have rotary motion. And of course, we had reciprocating motion, which is now reciprocating motion. Always remember, even if we don't talk about it, wherever you are connecting the piston rod to the crankshaft, there must be bearings. There must be bearings. Bearings are very important. There must be bearings. This facilitates rotary motion. Similarly, this rod is connected. The piston through a pin. Let's just expand it a bit so that we are able to bring in the pin element. There's a pin connecting the rod to the piston cap. Connecting the rod to the piston cap. Again, when that one, there has to be a bearing. There has to be a bearing to facilitate that rotary motion. Now, we have just seen in passing what we are talking about. We're talking about some very interesting unit. Now, for the four-stroke engine, we have several steps which happen in terms of the four processes. The first one is the intake stroke. During the intake stroke, let's just draw the schematic. During the intake stroke, we have our cylinder. We have our piston. We have our cylinder. Now, during the intake stroke, this piston is just about the TDC, just next to the top dead center. And so The inlet valve, like you have said, there is the exhaust valve and the intake valve. The intake valve opens. The intake valve opens, and the piston is pushed down, drawing in the air and fuel mixture. So piston pushed down, bottom dead center, drawing in air and fuel mixture. This ratio of air to fuel ratio is very important in terms of performance of these engines. So that setting for air and fuel ratio is set in the carburation system. The carburation system which deals with the fuel is the fuel unit in the engine. So that's where the mixtures are configured so that they are in the right ratios. They are in the right ratios so that you get proper burning, so that you have an efficient engine. So that when this fuel is burnt in the engine, what we call total oxidation of a substance, that's combustion. If it is a hydrocarbon, the way most fuels are, then it should burn completely. The hydrocarbon should burn completely to give you water plus oxygen, plus carbon dioxide. Water plus carbon dioxide. And so that's why if a vehicle is performing very well, you can see that water dripping out of the exhaust pipe. In certain cases, some of them produce a lot of carbon monoxide, so there's half combustion, so it's not very, very efficient combustion. That's not only dangerous, it pollutes the environment just as much as carbon dioxide also is a culprit up to a point. Now, when we have a piston air fuel mixture, piston air fuel mixture comes in, the piston moves down. So once it has been completely compressed, we have the next process. So we have the intake, and you have the compression stroke. So we have compression stroke. Remember the piston. Let's try to do it as best as we can. Should be perfectly fitting. Should be perfectly fitting. So that we have that stroke there. Now, remember, we had said that the valve, the inlet valve, intake valve was opened, the exhaust valve was closed. So now the intake valve is closed. Of course, the exhaust valve also is closed. And so we have the movement compressing the mixture. Mixture is compressed. So now we are not spending time writing the TDC and the BDC because you are now quite familiar with them. But now in the compression stroke, the piston moves up, compressing this air-fuel mixture, compressing the air-fuel mixture. In the vicinity of the top dead center, let me just try to keep that. In the vicinity of the top dead center, ignition is initiated. Now, if it's a petrol engine, like we have said, if it's a petrol engine, then in that particular case, you are going to use your spark plug to ignite that mixture. But if it is a diesel engine, then you will inject in fuel, and because the air is compressed, and the temperatures are high, the fuel mixture will be ignited and there will be combustion. So at that particular point, I repeat, the exhaust valve is closed, the intake valve is closed. So we have that ignition, and that corresponds to the power stroke. So we have the power stroke. Trying to do it as best as we can. Remember, the exhaust valve intake valves, intake valve, exhaust valve. Very important to always remember that still are closed. They are still closed. And so the piston is driven down because there's combustion. The air fuel mixture is ignited, they burn out, producing gases. High pressure system is generated in the system. The piston is moved, pushed down. The piston is pushed down. The piston is pushed down. Don't forget the rod. Piston is pushed down. So we have a lot of high pressure gases. High pressure generated by combustion of the fuel. And I repeat, combustion is total oxidation of a substance. Total oxidation of a substance. So if you have a hydrocarbon, then when it's totally oxidized, then you should get water and carbon dioxide as byproducts. And then it moves downward. Then we now reach when it reaches the bottom, the BDC. I guess you have to always write them TDC. When you reach the bottom, now we have the exhaust stroke. And the exhaust stroke, now you can have an idea. Remember, we talk of intake stroke. Now we have exhaust stroke. Here we have the piston. Remember, the TDC. We have our valves. TDC, let's put it at that. TDC. We have our valves. And now the piston is at the bottom here. The piston is at the bottom. This is the exhaust valve. It now opens. Intake valve is closed. And so when it reaches down there again now, because of those inertial actions of the crankshaft and so forth, the piston is moved, is pushed upwards, compressing whatever residual gases are here, resulting in the products of combustion. They are compressed. They are compressed, and of course, they exit through the exhaust valve, which actually leads into the exhaust system. Exhaust system. Which, if you look at the tail end of your car, you'll always see that pipe. That's called the exhaust pipe. But of course, the exhaust pipe also has a whole system. It's not just the pipe you see at the tail of the car. It has several things there, which facilitate this whole process. So basically, we have talked of the intake stroke, we have the compression stroke, we have the power stroke, and we have the exhaust stroke. Now let us look at this profile in terms of pressure volume profile for this engine. Let's look at the profile now. And very important, remember we have said we have spark ignition systems where you use the spark to ignite the mixture, and we have the compression ignition engine, where the air is compressed, the high temperatures when you inject fuel, of course, it's ignited. Now, let us look at the profile for the spark ignition engine. Spark ignition engine, we have that. Spark ignition engine. Initial pressure there, maximum, Vmax. And remember, during the intake, remember here, we have the intake valve. Open, intake valve open. But remember, the exhaust valve is closed. And then, of course, near the TDC, we have the intake valve. We have the compression. Remember, we have the compression. We are taking in the fuel mixture till about the BDC. Then we have compression. Let's say we have ignition at that point. That's where you ignite that mixture using the spark from the spark plug. This is compression. Then, of course, we now have the power stroke. You have already said what happens. You ignite it, gas, the products produced there, generate high pressure is generated in the unit, pushes down the piston. And then at some point here, we now have the exhaust valve open. Once it's open, like I've said, the piston is driven up, those residual gases exit through the exhaust system. Residual gases exit through the exhaust system. So that technically we can say that this, if we had that piston, if we had our piston here, that's the rod. If we had our piston, we can say that that corresponds to the TDC. And of course, based on how we have drawn this is a little bit exaggerated, then technically that would be the clearance volume. And of course, here we can say that would be about, that correspond to our BDC. So it will correspond to about our BDC. And now we have put it a little bit too far. Let's put it at about that point, our BDC. This is for the spark ignition engine. Spark ignition engine. Now, what about for the compression ignition engine? Compression ignition engine. The whole process is not any different. We again just have for our PV there, you have the same system. You just have the same system, but now this is the ignition point. You have the ignition point. This is compression. This is the power stroke. But the key catch here is this point here. Here now we have the fuel injection. Like I said, we now have the fuel injection at that particular point. The whole processes are the same. Intake, the air fuel mixture brought in. Then we have the compression, it is compressed up to about the TDC. Then we have the ignition, that's where the systems differ. If it is spark ignition, it's ignited using a spark plug, which ignites it. Or if it's, for example, a diesel engine, then you have the compressed air, whose temperature is pretty high when you inject the fuel, of course. it will be ignited. And then, of course, the power stroke and the whole process continues. The whole process continues. The whole process continues. So they are not very different. Most importantly, let us remember that these internal combustion engines are one of the most important inventions which man has come up with and cuts across the board in terms of powering the economies, where there's agricultural, transport, and everything. They all depend. If you're in agriculture, the tractors are all using those engines. If you're in transport, you have the motor vehicles, you have the aeroplanes, and so forth. So it's a very important invention which one needs to be conversant with. We'll stop at that point. We'll continue with our lectures next time.